Everyone, today we are going to study the different types of functions. This is the part 5. The first function is polynomial function. So what is polynomial function? A function which is written in the form f of x is equal to a0 plus a1x plus a2x square plus, in this way, last term is an x power n. So this is the general form of polynomial. Here a0, a1, an are called coefficients, and an, especially an, only an is called leading coefficient. Leading coefficients. This an xn is called leading term. A0 is called absolute term. If we give one restriction that this number, this constant is non-zero, then the degree of this polynomial will be the highest power of the variable, that is n. So in that case, degree will be n. Okay, now every polynomial function is a continuous function. Every polynomial function is a continuous function. Now, one important result I want to discuss is that if I have this polynomial result, this polynomial equation f of x into f of 1 by x, which is equal to f of x plus f of 1 by x. If I have this result, then this fx must be 1 plus and minus x power n. Only two polynomials satisfy this one. If I consider fx is non-zero. Now let's see the proof. Proof is very easy. Shift the term, this first term, fx, to the left side and take fx common. What we have, f of 1 by x minus 1 is equal to, right hand side is f of 1 by x. From here I am going to find out f of x, which is equal to f of 1 by x divided by f of 1 by x minus 1. Okay, this I am calling equation 1. Find out f of 1 by x, so it will be f of x and then f of x minus 1. Call this one as 2. Now our target is we multiply 1 and 2. Okay, now. So if I multiply 1 and 2, 1 multiply 2, what I observe that on the left hand side I have f of x multiply f of 1 by x. On the right hand side I have f of x multiply with f of 1 by x. And in the denominator I have the product of these two, this one. So it is f of 1 by x minus 1 multiply f of x minus 1. Okay, na? This one. So these two part cancel out because our polynomial is non-zero. The product of this is only 1. So what I have, f of 1 by x minus 1 multiply f of x minus 1, and this product is 1. I am calling this one is 3. So now fx is what? Fx is a polynomial. Fx is a polynomial. So now their product is 1. Here you have only one possibility. If you have f of x minus 1, this is equal to x power n, then f of 1 by x minus 1 is also 1 by x to the power n, and their product is 1. Again, if you have f of x minus 1 is equal to x power n minus x power n, to f of 1 by x minus 1 you have again minus 1 by x whole power n. So their product is again 1. So what we observe that there are two possibilities from this. The fx will be either take 1 on this side, so 1 plus x power n or 1 minus x power n. No other polynomial satisfies this result. Okay now? So during the problem solving we required this one. I hope this part is clear to everyone. What is the domain of the polynomial and range of the polynomial? So for the polynomial function, you can say that its domain is set of real number. And what about the range? So range depend on the degree of the polynomial. So range for odd degree polynomial, it is minus infinity to plus infinity. If it is odd degree polynomial, suppose we have here, suppose we have f of x is x cube, odd degree polynomial. If you take f of plus infinity, you will get answer is plus infinity. If you take x tends to minus infinity, answer will be minus infinity. So odd degree polynomial having the range minus infinity to plus infinity, whereas if you have even degree polynomial, suppose x power 4, so this is nothing but some subset of the real number you will get. So for the even degree polynomial, you will have the range will be the subset of, not even is a subset, if the polynomial is even degree, then your range will be subset of real number. This is for range. Okay now? Or you can write in this way. Range of the function f subset of real number. For the even degree, subset of real number. This is the notation of subset. This one. So I hope this part is clear to everyone. This part is clear to everyone. So just recap it. What is polynomial? Standard form is this one. These are called coefficient. An is the leading coefficient. An x power n is the leading term. N is the degree of the polynomial. If it is non-zero, and polynomial is a continuous function, domain of the polynomial set of real number, range is the minus infinity to plus infinity set of all real number. If it is the odd polynomial, if it is the even, then it is the subset of real number. Fx into f of 1 by x is equal to fx plus f of 1 by x. Then what we have, fx must have 1 plus minus x to the power n. Coming to the algebraic function. So now we have this operation plus, minus, multiplication, divisions, and root. Any root, cubic root, third root, fourth root, even root, odd root, whatever you apply. If you apply on the polynomial, then whatever you are getting, this is the algebraic function. For example, if I have here 16x power 4 plus 5x divided by, or you can say that half, and here I am taking x square minus 1. So this is the example of the algebraic functions. So if you apply these operations, 4 operation including the root, that is the fifth. So if you apply this type of operation on a polynomial, whatever you are obtaining, then that is called the algebraic function. So domain of this algebraic function is denominator should be not equal to 0. So for these algebraic functions, domain should be x square minus 1 not equal to 0, x cannot be equal to plus minus 1. So required domain is set of all real number minus plus minus 1. From this definition, it is clear that every polynomial is an algebraic function. So every polynomial is a algebraic function. Is an algebraic function, but the converse is not true. But the converse is not true. Converse is not true. So every algebraic function did not necessarily be the polynomial, but every polynomial is the algebraic functions according to the definition of algebraic function. Now suppose a function which is not algebraic. Consider some example like trigonometric function, like this. Inverse function, if you take like tan inverse, sine inverse, like that. Hyperbolic function, if I take sine hyperbolic x, like this one. Exponential function, I am assuming a power x. Logarithmic function I have like this one. So these functions which are not obtained from the polynomial directly by applying this operation, so these functions we called what? Transcendental function. Transcendental function. So transcendental function is what? The function which is non-algebraic function. Non-algebraic. So non-algebraic is called transcendental function. Next is fractional rational function. So rational function I am denoting by r for the variable x. It is equal to some polynomial px divided by some polynomial qx. So polynomial by polynomial is the rational function, where this polynomial should not be 0. So consider one example like x square plus x plus 1, and here I am taking x square minus x plus 1. So this is the example of a rational function. Okay now. So domain is what? Where it is non-zero. So domain for the function denominator cannot be 0. This is enough. Coming to this part, exponential function. So be careful, if I take here 2 power x and versus x power 2. Here what is you noticing? It is the constant. It is constant and it is the variable. So this type of things when you have, it is called the exponential function. And here you notice that it is base. So base is the variable. Base is the variable and it is constant. It is algebraic function. So this one is the algebraic function. Here it is polynomial. So it is actually the exponential function and it is one algebraic function. Okay now. So this is the difference. You can very clearly notice that. So 2 to the power x is an exponential function. So constant to the power variable. BLE. RIAB variable. Now in exponential function, if I have very well known e power x. So what is the domain of this function? E power x, and what is the range of this function? Okay, if I have the function here e power x, what is its domain and range? So notice that e power x look like this one. So domain is the set of all values of x. You can put any values. So domain is the set of real number, but your curve is lying above the x-axis. So range is the r plus. Okay now. So exponential function cannot be negative. If I have e to the power 1 by x, now what is the domain? So in case of e to the power 1 by x, you can put, suppose if you put x equal to infinity, or if you can put x equal to 0, then what will happen? 1 by 0. So 1 by 0 is the infinity, tending to infinity. E to the power infinity tends to infinity. So therefore in the domain, what is the restriction? Which number I cannot put 0? So domain will be set of all real number minus 0. Okay now. What is our range? What is our range? So e to the power range is what? You can put here okay. if you put here 1 by 0, you will getting e to the power infinity, which tends to infinity. So for this reason 0 is removed from here, because for x is 0, the output is not real. What is the range? What is the range of this function? If x tends to infinity, then 1 by infinity tends to 0 and e power 0 tends to 1. So when x tends to infinity, then it tends to 1, but x cannot be infinity, so this number cannot be 1. So range will be r minus 1. I think this part is clear. E to the power limit, if you take x tends to infinity 1 by x, so what will happen? 1 by infinity, so that is 0, that is 1. So limiting value is 1. Okay now, but x cannot attain the value infinity, therefore your function will not attain the value 1. So it is r minus 1. I hope this part is clear to everyone. Now I am taking another function 1 by ln x. Logarithmic function if you take, then what will happen? Acha, logarithmic function we define in the next slide. So this is the exponential function and their important domain and range. Coming to the logarithmic function, so a power x, suppose your function fx, a power x can be written as e to the power ln x a base x. Okay now? So from here you can represent the logarithmic functions. Okay, one more thing. Now here what we can say that since a is the input of log, so a cannot be here a should be 0, but a cannot be 1. Should be 0, cannot be 1. Okay. So now this is where we get the logarithmic. We can express the exponential in the terms of logarithmic exponential, and we can connect the logarithmic function. So if I have a function fx which is equal to suppose ln x, or you can say like that log of x base e. So here it is defined when x is positive, a is positive, but a cannot be 1. So in this range we can define the logarithmic function. Now the graph of these logarithmic functions look like this one. Okay, here when a greater than 1, then you have this type of graph, log of x base a. This one you have when you have a less than 1, then this curve is for log of x base a. Log of x base a when a less than 1. Okay now, here they intersect at the point 1, 0. So what we notice that here for a greater than 1, minus infinity to plus infinity is the range. Domain is fixed, x should be the positive, but in both the cases range will be what? Range of the function is from minus infinity to plus infinity. Okay now. So for a greater than 1, it is the increasing function, and for yellow curve it is the decreasing one. It is the decreasing function, and for the white curve it is the increasing curve. Okay now. Now domain and range we find from here. If I have this type of log, then what is the domain and the range? If it is in the denominator, domain and range is what? If you put x is equal to 1, then ln 1 is 0 and 1 by 0 is infinity. So x you cannot put 1. So from the set of real number which is positive, you have to subtract 1. What is the range in this case? Now this number cannot be, whole number cannot be 0, because 1 by 0 becomes a infinity. Okay now. So if you want to calculate the range, so range will be, what you can say about the range. If I put here 0, ln 0 is infinity, 1 by infinity is 0. 1 by infinity is 0. If it is tending to 0 or infinity, then what will happen? Think about that. You can say that 1 by ln 0. 1 by ln 0 plus. So if you take ln 0 plus this curve, ln 0 plus, so that means going to 1 by infinity. that means 0 will come. So therefore in your answer 0 should be excluded. Number 1, if you put here infinity, so 1 by ln infinity is infinity, so 1 by infinity is 0. Here 1 by 0 plus means you are going to 0 plus infinity, 1 by infinity is 0, and at the point infinity you will get the positive infinity. Okay, so what we observe that range will be 0 to infinity. Okay, any number it can take. From 0 to infinity it will take any number. At 0, yes, 1 by negative infinity, that is the tending to 0 plus. So now this is the logarithmic function, basic concept of logarithmic function. Now coming to the absolute value function. Absolute value function generally written as f of x is equal to mod of x, which is equal to x when x is greater or equal to 0, minus of x when x is less than 0. If you look its curve, its curves will be look like the V shape. Its curve will be look like the V shape. Okay na? Continuous curve it is, look like the V shape. So from here you can find if it is mod of x, then its domain will be anything. Domain will be the set of real number, but range you can notice that range is equal to 0 to infinity. From 0 to infinity is the range. This portion is the range above the y-axis including the 0, and this portion is the x dash and it is x. X dash is the x dash is the range. It is known as the absolute value function. Domain is clear, range is clear, graph is clear, and this function is continuous also. Then what we can say that anything else. Now if I going to calculate 1 by mod of x, what is its domain? So its domain will be what? For this function domain, if you put here 0, it will be 1 by 0, that is infinity. So any real number you can take, but except 0. Now what is the range of this function? Range of this function, whatever you are inserting, you will get a positive quantity, but this quantity can never become the 0. So 0 to infinity open bracket, here close bracket. Here this function can take 0 value, but here it can't take 0 value. If you put 1 by 0, it will become the infinity. Coming to the signum function, it is defined as sgn x, which is equal to 1. If your input is positive, which is equal to 0. If your input is 0, which is equal to minus 1 if your input is negative. Signum of x. Okay. Now if you are going to calculate, example, signum of x square minus 1, what you are getting? It is 1 when x square minus 1 greater than 0. This will imply mod of x greater than 1. It is 0 when x square minus 1 input is 0. This will imply x is equal to 0. It is minus 1 when x square minus 1 less than 0. It will imply mod of x lesser than 1. So in this way we can define it. Now you can say that similarly signum of x is nothing but signum x. Same result you will obtain. You can do it in do yourself this part. Now what we can say that what is the domain of this function, where it is defined? You can take any real number. What is the range of this function? Range of this function is only 3 points it has, minus 1, 0 and 1, minus 1, 0 and 1. If you look at the graph of this function, you will notice that now if you have here 1 and it is minus 1, so when it is positive the curve is breaking at the point 0, but after 0 it is continuously growing and it is y is equal to 1. And if it is less than 0, if it is less than 0, then we have this curve y is equal to minus 1. Okay now, here is the discontinuity. At the point 0, more than 0 it is 1, less than 0 it is minus 1, exactly at the point 0 it is the 0. So now your curve has the 3 parts, but all together they represent the signum function. So signum function is sometimes written as SGNX, and it is sometimes written as x by mod x, or sometimes it is written as mod x by x. Okay now, mod x by x. Next is greatest integer function, or it is also known as step up function. It is generally denoted by box of x. It is generally denoted by box of x. If I want to calculate box of 2.1, it is nothing but 2. The reason is what? Suppose it is 2, it is 2.1, it is 3. So if the number is non-integer, if a number is non-integer, then if you want to calculate its box function, you have to move from that point to the left hand side. So first integer will be the answer. Okay now, so if you take like minus 3.5, so minus 3.5 is some negative number. If it is 0 here, it is suppose the 3.5 negative, so there will be the minus 4. So now if you take the box of minus 3.5, you will get minus 4, because 3.5 is not the integer, so you have to move to the left hand side. The first integer will be the answer. Answer is minus 4. But the problem is, if it is not a problem, it is a definition. If it is 2 integer, then no need to move left hand side. The answer is the 2. So in this way we have the idea of the greatest integer functions. So now coming to the formal definitions of it. So first of all, what is the domain? What is the domain of this function? If I have box of x, so in domain you can put anything, box of x. If your function is fx equal to box of x, so then domain will be the set of real number. Now what is the range? What we notice that only integer will come after solving. Okay now, so its graph is very important. From 0 to 1. At the point 0, box of 0 is 0. At the point 1, box of 1 is here. Between 0 to 1. Between 0 to 1, if it is 1, between 0 to 1, if you choose any number here, then you move to the left hand side, first answer is 0. That means 0 to 1, between 0 to 1, its box is this one. At the point 1, there is a 1 empty circle. So this empty circle for what? To indicate that value is not 1, value is not 0, value is actually 1. So from 1 to 2, at the point 1, the box value is 1. At the point 2, box value is 2. So between 1 and 2, answer is always 1. At the point 2, there is a gap. The value is not this one, the value is this one. Similar way, you have like this. So in this way, you will get the graph of the box function. It is minus 1, it is minus 2. Okay now. So here y is equal to 1, here y is equal to 2, here y is equal to 3, here y is equal to minus 1, here y is equal to minus 2. So step by step you are going upward direction. So that's why it is known as also the step functions. So when x lying between 0 to 1, so its box, corresponding box will be, its corresponding box will be 0. If it is 1 lesser than x lesser than 2, then the corresponding box is 1. If it is 2 less than x less than 3, its corresponding box is 2. So in this way we are going to find out the box function and its corresponding graph. Now next is, if suppose f of x is equal to 1 by box of x, can we find out its domain and range? So what is its domain? What is the domain of this function? Domain of f. So for box x, if this part is 0, then 1 by 0 is infinity, so I don't want this part. So in the domain, I have to subtract those x for which it's become 0. So it's become 0 from 0 to 1. So I don't take this value. From 0 to 1, I have to subtract. What is the range of this function? So range is what? Every time you are getting the integer. So now range will be such type of number 1 by n. But in this n, what I have set of all 1 by n, notice that every integer will come here, but except 0. 0 will not come. So from the set of all integers, I, you have to subtract the 0. So your n will be this one. Set of all integers I minus 0. You can't take 0 here. So this is the range of the function fx equal to 1 by x. Now some properties you have to memorize for this box function. Number 1, always see that when you are going to take the box of a number, you have to move towards the left. And you know that if two numbers are there, left hand side is always lesser. So box of a number, box of any number cannot be greater than that number. Box of a number is always less than that number or equal that number if it is integer. So this also says that the box of a number is always greater than the number minus 1. The number minus 1 less than box of x less than equal to x. Okay, now this definition also you can change and you write in this way: x is greater than equal to box of x and this x lesser than box of x plus 1. Third one, if you are going to calculate box of x plus some integer m, since it is the integer, it will be outside of the box. You have only this one. Fourth number point, suppose box of x plus box of minus x you are going to calculate. What will happen? If it is integer, 2 plus of minus 2, it is 0. So for integer it is 0 when x belongs to y. If it is not integer, then you have minus 1. Suppose it is 2.1, it is minus 2.1, it will give you minus 3, it will give you plus 2. So answer is always minus 1 for the non-integer number. This part is clear. Box of x plus box of minus x equal to 0 for x is integer, and if it is not integer, then always you are getting the minus 1. I hope this part is clear to everyone. These 4 properties is enough. There are so many properties, but those properties are not required so much to solve the question. If you know the basic definitions, if you know these basic 4 properties, then we can solve the maximum questions. You have to practice the graph also. Fractional part functions is denoted by in this way, curly bracket, and x is inside the curly bracket, which is equal to box of x minus box of x, which is equal to x minus box of x, which is equal to x minus box of x. So now what is the if you draw the graph of this function, suppose 0 to 1. 0 to 1, whatever you are taking the value, if you take 0, you will get here 0 minus box of 0 is 0. If you take 1, it will be 1 minus 1, again 0, here you are taking. If you take 0.9, so 0.9 minus box of 0.9 is 0, that means you are here. So at the point 0.9, you are actually here, just less than 1. So therefore, every point you are taking, you will get this point, and you join, you will get this one. So at the point 1, it is 0. Other than 1, the curve will be look like this. Same happened from 1 to 2, this one. Same happened from 2 to 3, like this one. So it making a 45-degree angle with the positive direction of x-axis, and it cannot reach the value 1. Every time it is positive. For minus 1 to 0, it will be look like this. Minus 2 to 1, it will be look like this one. Okay, na? So from the graph you can say that the domain of the function is what? So for this function, if you called fx is equal to fractional part of x, then what we have, domain of the function, whatever you can insert, it's your wish. So it will be always set of all real number. Range of the function, you notice that it is starting from 0, but you cannot reach 1. At the point 1, again it is 0. So minimum value 0, maximum less than 1. Okay, now so 0 to 1 is the range of the fractional part function. Okay, and graph is clear. I think everyone can find out the, or you have to practice this graph also. Now if I have this function, what is the domain and range of this one? Like this one, if I have g, or you can say that this function 1 by fractional part of x. If I have this is my fx, this one, then what is the domain and what is the range of this function? So domain is what? You notice that as at the integral point it is 0. At the point 0 the fractional part is 0, at the point 1 it is 0, at the point 2 it is 0, at the point 3 it is 0, at the minus 1, at the minus 2. So that means you can't take the integral point because this point becomes the 0. The denominator becomes 0, that means whole fractions will become the infinity. So therefore set of all real number minus the set of integer will be the domain. What will happen to the range function? So range will be just reciprocal of this one. So reciprocal of 0 will goes to infinity, and reciprocal of 1 will be 1 only. So you have more than 1, less than infinity. This will be the range of this fractional part function. So I hope this part is clear to everyone. Coming to the some properties. First properties, we know that fractional part of x is greater or equal to 0 but less than 1. Second is, if you have any number m which is integer, and if you take the fractional part of x and merge it and going to calculate fractional part of these two, you will get only fractional part. For integral part you 0 have the fractional part. Now next is, if you have the fractional part of x plus fractional part of minus x, what will happen? Suppose it is 2, so 2 of minus 2, so this fractional part is 0, here fractional part is 0, so we have 0 only. X belongs to the integer. If x does not belongs to the integer, if it is not integer, 2 and minus 2.1. For the 2 you have 0, for minus 2.1 you have 0.9 only. Again I am repeating, suppose it is 2.1 fractional part and it is minus 2.1. So from here you have 0.1, since it is the negative number, so when you are going to calculate its box fractional part of x, so you have to find out, you have to find in this way, fractional part of minus 2.1. This can be written as, because fractional part is always lying between 0 to 1, so this will be minus 2 minus 0.1. This can be written as minus 3 plus 0.9. And you know that since it is the integral part, so it becomes the 0, for you have to take only 0.9 fractional part, which is 0.9. So this will be actually 0.9. So minus 0.1 plus 0.9, so it will be plus 1, not minus 1, it is plus 1. In case of box we have the minus 1 and here you will get the plus 1. So this part is very important. These three properties you have to memorize. Coming to the identity function is written as f of x equal to x. If you look at the graph of this function, it is nothing but the straight line making 45-degree angle with the positive direction of x-axis, like this one. So slope is what? M is equal to 1. It is 45-degree angle. From here to here curve is moving. That means domain of the function is the set of all real number, and range is also the set of all real number. So domain is equal to range is equal to set of all real number. Whatever you give as input, you will get the output as well, same. Constant function, suppose I have this curve y is equal to c, it intersects when x is 0 here at the point at the 0 comma c. It is our coordinate system, xo x dash, this one is yo y dash. So now whatever the function is written like that, whatever you give as a input, output is always fixed. So it is nothing but a singleton set. Domain of this function, domain of the function is the set of all real number. Okay now. What is the range of this function? Range of this function is the singleton set C. Okay. Now few example of this one. Take any fractional part. Now take its box. Fractional part, suppose 0.9, or fractional part always lie between 0 to 1. So if you take any number 0 to 1 and you are going to calculate the integral part, it will be the 0. Now take the box function. It is integer, and since it is integer, its integral part is 0. So this is the example 1, example 2. Example 3 is if you take sin square x plus cos square x, and this function is always the constant function 1. So you can write fx. This one is constant. This one is a constant function. This is also a constant function. Fourth example you can take like this. F of x as signum of x square plus x plus 1. So signum of positive number is 1 only. Okay, na? So these are the few example of the constant function. There are so many functions in your book as example. So today we have completed the different types of function. In the next class we will do some new things. Till then, bye. Have a nice day.